a few years ago, there was a paper that came out in Nature Geoscience by Otto et al. And they basically looked at the 20th century observational record, and they calculated a relatively low climate sensitivity, about 1.5 to 2 degrees Celsius. And then a bunch of other papers came out which essentially confirmed that result. And so that created a big problem in the scientific community, because we have these climate models that predict 3 degrees Celsius for doubled carbon dioxide, 3 degrees Celsius of warming for doubled carbon dioxide. Then you have this observational record that was predicting 1.5 to 2 degrees. And you've got other data. You've got paleoclimate data. You've got calculations of individual feedbacks, and if you add them up, should give you the climate sensitivity. So over the last few years, the scientific community has made enormous strides in understanding the 20th century record and how that influences our estimates of ECS, of equilibrium climate sensitivity. And I think now it's quite clear that those estimates of low ECS, climate sensitivity, during the 20th century are too low. They don't actually reflect the real ECS of our climate system. And that's because of internal variability, meaning just sort of random fluctuations, things like El Nino cycles, weather noise, these things that are on top of the long-term warming trend that we're experiencing. And so those things are confounding our estimates of climate sensitivity from the 20th century record in a way that tells that implies a lower climate sensitivity than reality. And so you know, what's happened here is what's happened to all of the skeptical arguments. You know, in the 2000s, it was the surface temperature record isn't reliable because all of these thermometers are next to air conditioners. So that was investigated and that was rejected. And then global warming stopped in 1998. Well, it restarted. So that idea has been discarded. So this idea that climate sensitivity from observations is a lot lower than the models, or the models are running hot, that's headed for the junkyard of discredited ideas of climate skeptics. And in a year or two, nobody except the true dead-enders are going to be making that claim. So I think the reconciliation of this problem is going to be that the estimates of low ECS are wrong, and that the models and the paleoclimate data are right. And that's just, again, because of its methodological problem in how you estimate climate sensitivity from a 100-year record. And there are lots of problems with that kind of get brushed under the rug in most public debates. You know, we don't really know what the forcing has been, what we call forcing, which is how humans are impacting the energy balance of the planet, because we don't really understand how aerosols affect clouds. Then there are also data measurement errors. We don't really know how much heat's going to the ocean, although that's actually getting a lot better. And so I think we actually do have a much better handle on this now than we did, you know, when the AR5 was written. So I think the resolution is going to be high climate sensitivity, or maybe not high, but higher than the low end of the IPCC record, so 3 to 4, somewhere around there is sort of my best guess now. Brown and Caldera concluded that the climate sensitivity, sort of their mid-range estimate was 3.7. So that sounds reasonable. I mean, I think that's in the neighborhood of where it'll end up. I have an analysis, not yet published, of course, that indicates 2.4 to 4.4. So that gives you a midpoint of about 3.4. So, you know, I think that's a lot of the evidence is pointing to the mid-3s now. I think I'm still not a believer in climate sensitivity above the IPCC's high end of the range, 4.5. I think it's really hard to get there. And I see no evidence for low values. And the important thing here is we now can explain why the observational record is giving us such low values. And we can explain that in ways that it doesn't affect our estimate of ECS from these other ways. Yeah, okay, so we can explain the low ECS by understanding the pattern of warming. So if I tell you there's 1 degree Celsius of warming, there are lots of different ways you could distribute that. So you could have lots of warming in the Arctic, you could have warming in the tropics. In the tropics, you have warming in the East Pacific or the West Pacific. So the pattern of warming has been such that there's been a lot of warming in the West Pacific, but not a lot of warming in the Eastern Pacific. And that pattern of warming, when you plug it into the methodology that you use to extract ECS from the 20th century record, gives you a lower ECS than if you had had a different amount of warming, if the warming had been distributed differently, but the same amount of warming. And so depending on how the warming is distributed, you can get completely different answers for the climate sensitivity. And so it turns out that these estimates of 20th century, or estimates of ECS based on the 20th century are not precise. they can give you a whole range of answers, some of which are close to reality, but some of which are not close to reality, just based on how the warming is distributed around the globe. And the pattern of warming that we've had has, I guess you can see it's either good luck or bad luck. It's implied a lower climate sensitivity than it appears the climate system really has. We're kind of pushing the needle a little bit to the north when it comes to climate sensitivity. I mean, for the last 20 years, I've had this number in my head, which is 2.7 for climate sensitivity, and I think I'm now beginning to revise that upward to now 3.4. So you know, it could go back down. I'm always open to new data, but I think that there's a lot of data now that suggests that climate sensitivity is probably a little bit higher, and we now understand why the arguments that climate sensitivity is low are probably wrong.